Good morning. Happy Thursday. Today we're going to continue to be focusing on the number of solutions to an equation. Our specific focus is going to be which types of equations, again, are going to be producing infinite solutions or have a never-ending number of solutions. Every number in the world works. And which type of equations are going to be producing no solution where no number in the world is going to be able to make the equation a true statement. So I'm going to flip to the whiteboard right away as we get started on this. If you take a look at today's objectives and key terms, they're similar to yesterday. Again, our big focus is that some equations are going to have no solutions. Something like x plus 1 equals x plus 2 could never be a true statement, so there just are no solutions to that equation. And some equations will have infinite solutions because they're really just equivalent expressions. X plus 2 equals 2 plus x. No matter what I plug in for x, this equation would always produce a true statement. Before we get looking at the guided problems and have you explore that, we're going to review yesterday's practice problem number 4. At this point, we expect that you understand a problem like this, some of these simpler equations, which ones are going to produce no solutions, which ones are going to produce one solution, and which ones would produce infinite solutions. If you take a look at my whiteboard, I'm going to look at the first one we showed with infinite solutions from problem 4 yesterday. That was 5x plus 2 equals 2 plus 5x. The reason that this has infinite solutions, what we started to see, is the left expression, a positive 5x combined with a positive 2, is the same thing as the right expression, a positive 5x combined with a positive 2. So no matter what I plug in for x, maybe x is equal to 1, then I'll get 5 plus 2 equals 2 plus 5, and that just says 7 equals 7. If I plug in a different number for x, if I make x equal to 10, 5 times 10 would give us 50. I'd have 50 plus 2 equals 2 plus 50. So because these are equivalent expressions on the left side and right side, it doesn't matter what value I pick for x. At the end of the day, there was an infinite number of solutions to that red equation. Same thing with the green equation here. We see 3x plus 12 is really just the same thing as saying 12 plus 3x. So what do we recognize? For infinite solutions, if you have the same coefficient on the variable on both sides and they're added with the same constant term, we're going to end up with infinite solutions because it's really just the same expression on both sides of the equation. We also saw examples of no solutions. Problem 4, you should be familiar at this point now why 3x plus 25 equals 3x plus 14 could never be a true statement. If you take a look at this, and we're going to full screen again in a second, 3x plus 25 equals 3x plus 14. We should now be recognizing this equation can't have any solutions. Let's see a quick example why. It's the same variable term on both sides, positive 3 times x, positive 3 times x. So no matter what I pick for x, this side gets 25 added, this side gets 14 added. So if I make x equal to 1, if x were equal to 1, I would have 3 times 1, that's just 3 plus 25, and that's never going to equal 3 plus 14 because this side gets 11 more added than that side. Same thing if I pick x is equal to 10, 3 times 10 is 30, so I get 30 plus 25. That's not going to equal 3 times 10, 30 plus 14. Doesn't matter what I pick for x, this side is always going to get 25 added, this side only gets 14 added. There is just no solution to an equation like this when we see the same variable term with the same coefficient, but we see a different constant term combined with it on opposite expressions. And perhaps the biggest thing we should maybe start seeing is if the coefficients for the variables on opposite sides are different, a 3x and a 2x, we're going to end up with one solution. That's what we're going to explore a little more today too. So for the first guided problem today, you're given an equation with a blank box. We could call that a magic box. And they're saying if x minus 4 is equal to negative 4 plus some unknown term that we're going to plug in here, what could we insert or plug in for that unknown term, for that purple box, that would give the equation an infinite number of solutions? And again, I'd encourage you to remember what kind of goes on the structure of equations that have infinite solutions. Same variable with the same coefficient, and then added with the same constant term, or maybe subtracted with the same constant term. Just go ahead, pause the video, try to figure out what could be inserted for the purple box there. And I'm also, as you're going to pause this video, you're going to take some time to work through part 2 on your own, where they say this equation, 3x plus 8 equals 3x plus some unknown box. What could you plug in for the unknown box to give it no solutions, to give it infinite solutions, or to give it exactly one solution? So pause the video, think about that. I would encourage you to talk with your neighbor right now too. And on your own, you all should definitely be able to figure out part 1 and part 2. But when you come back after your discussion with your neighbor and thinking on your own, I'll show you what I got. Welcome back. Hopefully you figured this out. So if we have x minus 4 equals negative 4 plus something we don't know yet, and they want us to have infinite solutions, remember the key is same variable on both sides with the same coefficient, and they need the same constant added. Here, as I'll full screen the whiteboard, we have the same coefficient, sorry, not coefficient, we have the same constant term, negative 4 over here, negative 4 over there. So we would need this box, the unknown one, to have the same exact variable term so that we're doing the same expression or equivalent expressions. What do I need to plug in here? Hopefully you all figured out that all we need to do is put in a plus x there. And if we put in a plus x right there, if we delete that, 1 second. If we delete that and put an x, positive x combined with negative 4, same thing as positive x combined with negative 4. Now this would have infinite solutions. For part 2, I'm going to full screen this. Give me 1 second to clean that up. We have a new equation. I'm going to put that onto the whiteboard, and they're asking us 3 scenarios now. 3x plus 8 equals 3x plus whatever term you want to plug in for this box. How do we make this equation have no solutions? The key for no solutions, you should see they have the same coefficient with their variables, just like we have here today, 3x and 3x, but a different constant. So the answer is anything I want, plus 5, plus 7. The answer really is any constant, that's just a regular number, other than positive 8. Because if we put positive 8, that's the only way we're going to make this equation have infinite solutions. If I plug in positive 8 to this equation, for that blank box, now the expressions on both sides are equivalent. I would have created an equation with infinite solutions. Probably the trickiest part, how do I make this equation? What do I put into this blank box so it has exactly one solution? What we should have seen yesterday and start to learn better today is the way we get one solution, if variable terms are on both sides, they need to have a different coefficient. If the coefficient is the same for the variable on both sides, like we currently have with 3x and 3x, they're going to cancel each other out, and it's either infinite solutions or no solutions. So what we need to do is get this to be the right expression to be something other than 3x so that it doesn't eliminate the 3x on the opposite expression. Easiest, simplest thing, if I turn that into x, 3x plus x becomes 4x. Now, as you look at this whiteboard, I don't have to go further to know that this equation has just one solution. The 4x over here, the 3x over there won't eliminate on both sides. Instead, I'll be able to gather x's on one side, constants on the other. It doesn't really so much matter what the solution is here. They just wanted us to create an equation that got one solution. So I could have put x. I could have put something more exciting like negative 5x, because if I had put negative 5x, 3x minus 5x, would have given us a negative 2x in this equation as well. It'd be a more difficult solution, a decimal answer at the end, but this equation is going to have one solution because the x's can be gathered over here, the constants on the other side. So again, pretty much any x term here would give us one solution because the x's wouldn't cancel out. The optional challenge problem is down here. I'm going to encourage you to skip that and get going on the practice problems, but this is the kind of equation you might see as the most difficult equation maybe on the MCAS, maybe on the Illuminate when we take that in a couple months. If you need help working through this, and do try to do it, work with a neighbor first and then put your name on classroom queue. Thanks for listening to the end of the video. Happy Thursday and good luck on the rest of the work. Last thing,